I came to the conclusion that most developers start building their backends in the same way, and until the moment that they are finally building their scalable, reliable systems, they usually go to 3 different stages. And if you know those, you can get there faster. And it's about those that we'll talk about now. What I will show you is the basic learning stages of that journey. However, each different stage, each different phase works as a building block to the next stages. That means that in the future, when you are in the final stage, you still use the concepts of the previous ones. The difference is that you start discovering different approaches. You start understanding when to use one approach, when to use another. That doesn't mean that you stop using them. Imagine it something like this. Imagine that you have here your start, okay? This is your starting point. You start here. And now you start acquiring a new experience, a new way of doing things. And how does that work? It works in the following way. You are here and you want to get here. This is your North Star, the place where you want to get, the place where you have your scalable system. Beautiful, elegant, reliable, all of that. And now you are far away. However, you start seeing what is happening around you. So you have a given scope that you can see, okay, given your vision can reach to a given point, but you can't see every single thing. You can't get there yet, okay? But this will work as the first thing that you will conquer. Eventually, you move forward and you start learning different things. You still don't see how to get there, but eventually you will conquer one more stage, and now you have not only the knowledge from the previous stages, but you have all of that as well. This is the broad scope of the idea. That doesn't mean that you don't need to dig into the basics of each one of those stages. However, the fundamentals, understanding the basic premises, understanding when to go with the techniques from this one on the top, when to go with the techniques of this one, when to just stay with the basics that you start doing here, that will be part of the learnings, okay? Eventually, one day you are still mixing those different techniques. So let's see, what does it mean? So when you build your first backends, you start always in the same way. You start with the principle of the request response. This is the first step of our journey. Okay? And this is where we start, but eventually we need to get out of here. Why? Because we start here for a simple reason. It's extremely simple. You get a request, you do something, and you send the response back. Okay? Request the something, response back. But this has some limitations. One of them is the time that this operation can take. So imagine that this request is to process a given set of data. For example, uploading a given file and trying to populate a given table. This request can time out. So eventually, it might fail because of the timeout. Then we have other possibilities like, what if I start my request, but eventually something goes wrong in the middle of the processing? So I'm going through that file, inserting data into a table, the request goes down, what happened? For example, if it's part of a transaction, I failed the complete request. Some part of the effort has been lost, okay, but at least I'm in a consistent state. If I don't have a transaction, it can be even worse. But the problem is when you lose part of the work that you have already done, okay? There's always the risk that, for example, you are going through 1,000 lines and the last one has a problem and now you lose every single thing. So you need to repeat the requests, bringing load into the system. The fact that you have this possibility of the work being lost and also the timeout, that means that now our user needs to wait for a long time until this thing happens. If this request response takes just a second, that's fine in some cases. But imagine that this starts taking 10 seconds, 20 seconds, almost a minute. I've seen that. So it can happen. Now you are giving a bad user experience. Because, for example, if this is an HTTP request and the user wants to cancel it in the middle, how do you do it? Do you abort every single thing when the HTTP request is canceled? What do you want to do? How do you want to deal with these type of problems? Okay, how do you inform the user that the request has failed? Okay, there's an expectation in a request response. Okay, that the user needs to be there waiting for every single thing to happen. This is a poor user experience. And one of the biggest problems with this is that this doesn't scale. Okay, so we have a scalability issue. Why? Because if you need to perform request to something response and you need to wait, that means that the number of requests that you have is the number of operations being done. That is a limitation, is a potential bottleneck in your system. Okay, you can reach the limits of your infrastructure and you can't delay work and you can't manage work in order to achieve it later. So if you have, for example, a spike in the load of your system, you are screwed. And usually it's because of these type of things that you want to progress to the next stage. Okay, and the next stage is when you start thinking about delaying operations. And this is when you start doing something that looks like a cron job. So there's a given schedule, and I will start working on the things that need to be done at a given pace. For example, imagine that on that case, I send that file to the server, okay, in my API instead of request, do something, response. The do something now is something quite simple like sending that file to somewhere. Okay. Now that file is inside of a folder, and every single hour, for example, there will be a cron job that will look into those files in that folder, unpack them, and send the data to where it should be. But now is when things are not as simple as it used to be, okay? It used to be quite simple. Usually you don't need to have a lot of monitoring to see if your system has things stuck in a given folder. And usually you just need to look into, for example, the errors that are happening in the interaction with your users, your clients. But here you need to start monitoring your own processes. You need to start taking a look if those jobs are running or not. And you need to bring that complexity on managing the failing state. For example, I'm processing something goes wrong. How do I inform the user that there's a problem there? Do I need to inform? Is something for a manager, an operational manager of your application to take a look? This is the type of considerations that now you need to have. So while this has some advantages when compared to the request response, like for example, it's still quite simple to achieve that. Okay, it's a natural evolution. It's not that hard to build something like this. However, there's this operational cost, okay, of maintaining, of observing how the system is running, but also this has another great advantage, that is now our system doesn't need to block the user. Okay, we can provide a better user experience, but we are increasing the complexity to achieve that. Okay, because now we need to have other ways to inform the user that something has happened, and that leads to some of the problems of this approach. Why? Because now I don't have that response immediately when something happened. So I need to bring that complexity of giving a proper user experience to my user, considering the fact that I have a cron job that is running. Okay, that might be running only after 5 minutes. That might be running after 1 hour. Okay, I still don't know the frequency when that thing will be running, but I want to provide a proper experience to my user, and it doesn't need to know about those technical details. So how to deal with that? So we have that problem of not real time. Okay. So I can't give that user experience anymore, and I need to find ways to achieve that. That is part of the complexity. Another problem with this approach is that if something goes wrong, if I'm delaying to do something to a few minutes later, and during that processing that thing, something goes wrong and the user needs to intervene, how do I implement the logics of retrying, for example, or react um, to a fail, to something that goes wrong? How do I go there and I fix the state of the system? How do I go there and retry the operation with a different set of data? All of that stuff. And also, another problem in terms of infrastructure is that while I don't have that problem of having a huge load at a given point, for example, and all of those requests need to be processed at the same time, I have traded that with other problems in terms of infrastructure optimization. And one of them is the fact that to understand if the job has been executed or not, I might need to do some kind of polling to the server, or I need to keep any persistent connection with my client. So I will have that cost of maintaining that. And by the way, since I'm talking about polling, if you want to see a video about long polling, please let me know, because I have that idea on my backlog for a long time and I'm not sure if it's interesting or not. But I've been thinking a lot about polling and long polling especially, and often we don't value the beauty of long polling, so it might be interesting. So if you want to see it, leave a comment, subscribe, and eventually it might show up in this channel. So as I was saying, now we have that problem with polling. So we are basically wasting resources doing this polling. I'm saying polling, but it's any type of system that we came up to the user to understand uh, the state of a given job. The thing that will take you to the next stage, to the final stage, where you start building those reliable systems, scalable systems, is the fact that even by doing this strategy, it's not ideal for those scenarios where you have a huge load. Why? Because it becomes hard to optimize the schedule of the cron job. Okay, if you come to a place where the load is so huge, you will still have the complexity of scaling the system and being able to scale that workload through different services based on a cron job. Also, if there's a ton of data, a ton of things to be done, eventually you need to adjust that limit to something that is quite small. So looks like it's every single time running. And this becomes extremely hard to manage. This becomes extremely hard to maintain. Besides the fact that you have this waste of resources regarding the polling, the status, and all of that. However, if it's an operation that you need to perform every single hour or every single day, it's not a huge thing. It will take you a few minutes to achieve and to complete every single thing in a run. It's perfect for that, okay? But there's other things that need a different strategy. So this one is not ideal for high volume. So once you start seeing the problems with this, you get to that scale where some operations need a different strategy. The almost real-time user experience needs to be there, all of that. We usually will get into the next stage. And that next stage is with what we call the event-driven way. So what does this mean? It means that those cron jobs, those background jobs, will not react anymore to a timer. They will need to start reacting to an event, to something like a queue, to a message in a given place. So when I get a request through that API, that backend that I've been building, I will send that request as a message to somewhere, as an event. I will record that. And then there will be something that will be looking into that place, something like a queue, and will realize that there's something new to be done. So I will pick that information, that request, that event, and I will start processing it, and then I can produce the output. What's the advantage? This will reduce that problem of the real time. While I still not in the place where I'm doing the request to something response, I can reduce that gap. Okay, and I can provide a better user experience for my user. Okay, it's almost real time. The user experience is almost real time. There's even some products that try to hide that part. Okay, that looks like something is happening on demand, but in fact is not. It's being delayed, but that's not the ideal. But for example, You place an order at Amazon. Eventually, you get an email saying, okay, we received your order. That order eventually triggered a given event that said to a given system that, okay, I have a new order. The order is confirmed. Let me inform my user. So it looks like that it was request response if we consider that clicking a button can have a response as an email, but that's the idea. And why is that? Because when we send to a queue and we have something to reacting to the queue, that queuing part is fast, can be fast. And it can be fast because now we have the possibility to scale it. If that request went to a given queue, so imagine you have your queue, and now you have a given process here. This is your event handler, the code that is reacting to that event on that queue, on that messaging system. Once I pick it, I can start processing it. So we can be extremely fast as far as we have other agents like this, other code like this, available to process messages coming here. What if I don't have it? The advantage of this approach is that now I can scale this part of my system independently. Okay, I can horizontally scale it, so that gives me the freedom that when I need to scale my system, I just need to have more things on this side. Okay, if I have a problem of this queue that keeps growing and some of those messages that are here have been here for a long time, I can just scale the system, bring some more workers in, and I can decrease that cap. I can start processing them faster. So that's the scalability part. Not only that, but each one of those here will work independently. Okay, they don't need each other to be successful. So that means that if this one is processing a given message and fails, it doesn't affect the other ones. What is a benefit and makes the system more reliable. And if that one has failed, it's quite easy to say, okay, this message here has failed, so I want to retry it and I will inject it again into the queue, for example. You have different types of techniques that you can do to, to reprocess things in an atomic way without impacting the workload of other requests, the server, all of that. And you do all of that while you keep the API that is ingesting those requests quite simple and easy to develop. But this is not only benefits, there's always some problems, right? And the biggest one, and you have noticed already, is the complexity that comes with it. Not only the complexity in terms of coding it, but the complexity in terms of infrastructure, of different pieces that now we need to maintain. We need to have those workers, we need to have a messaging system, something like a queue, we need to have observability to understand how the system is reacting, all of that. And that comes as a cost when we get to this stage of the scalability part. And we have the idempotency. That is something that we need to implement in order to avoid that, for example, duplicated messages, duplicated requests, messages processed twice, don't have an impact on the output of our system. For example, imagine processing twice the same financial transaction can have huge impact in the accounting system of your company, for example. It's not only the idempotency part, it's also all of that retry logic that is also complex. Okay, now you need to deal with a lot of different techniques in order to reprocess things. It will depend on the systems that you are working here, the way that you will implement stuff. You need to think about how the user will be able to do that. There's the operational part of this, like monitoring, logging, and all of that, and that brings complexity as well. So as you can see, we start in a simple way, the easiest way to achieve our result. Eventually, we start seeing some problems. And to react to those problems in terms of user experience, in terms of scalability, we can deal with some of them in a simple way, with a simple fix, with something that is not that complex. However, we are just moving the problems around. And eventually, if those problems become big enough, we need to start taking measures like this one. And usually the key magic part is when we start using messaging, when we start using events. That takes your system into scalability, into a scalable and reliable system. But doing all of that, doing that journey, starting here and coming to here, means that we have some trade-offs. Okay, now we are buying complexity, and we used to have a lot of simplicity when we're here. Okay, but we are gaining scalability. That means that there's always a trade-off on every single operation that we decide to go to the next level. Eventually, we will get here if our systems start to scale, if our systems become too important to fail. And eventually, we'll learn these things and get to this part of the event driven. However, let me tell you that is a huge mistake if you assume that once you get here, every single thing needs to be implemented this way. That's not the goal. I hope you like this video. Let me know in the comments if you like this style of video. And in the meanwhile, you might want to watch this one right here, and I will see you in the next one.